Okay, this lesson is going to be using the area model to solve multi-digit multiplication problems. Now, I'm going to be solving an area model with 4 parts and then with 2 parts. So you're going to be seeing both of these strategies. So, you're going to begin with 4 parts. And what I need to do is I need to turn my rectangle into an area model by knowing that my formula for area is area equals length times width, which means really this is an array, which is why we're using area model, because an array is a way to represent a multiplication sentence. So 37 on this side, 52 on this side, and basically I would have to say 52 times 37 would give me my area. The problem is I don't know how to do that. So what I'm going to do is I'm going to create 4 smaller problems that will allow me to do that. So the first thing I'm going to do is I'm going to break up 37 into 2 parts that I more easily understand, which is 30 and 7. I'm going to go ahead and use my place value. So from here to here, I'm going to say is a length of 30, and then from here to here is a length of 7. And I know that 30 plus 7 is the expanded form of 37. I'm going to do the same thing down here. I'm going to turn the paper a little bit so I can easily see it. And I'm going to break up 50 and 2. So I have 50 from here to here and 2 from here to here. So now, this is definitely not to scale, but it does help me break up my problems. So now I'm dealing with 4 different small rectangles. I'm going to color code them so I can easily see them. I have this rectangle up here. I'm going to color code this blue. Okay, I have the one right next to it, which I will color red. The one under red, I will color green. And this large one, the last one I will color orange. And I'm trying to color pretty fast so you can easily get this lesson in. Okay, so now basically I have 4 rectangles. You can see my 4 parts easily. But I have to represent the multiplication sentence to find the area for each one. So I have to know the length and the width for every single rectangle. Now, here, I know that my length from here to here is 2. So I know I'm going to multiply 2 times something. And I know my length from here to here is 30. Okay, so I need to find out this one. I know that from here to here is 50. Now, what is from here to here? Or I can find from here to here. The problem is I don't have those measurements. It's not written on the rectangle. So how can I find them? Well, I know that opposite sides of a rectangle are equal. So the opposite side of this rectangle is 30. So that means this is going to be 30, which means I have 50 times 30 is going to be my orange rectangle. Now let's move over here. We can go back to the top. I know from here to here that's easy. It's 7. It's labeled for me. But I don't know what is from here to here, from here to here. Where can I look? Remember, opposite sides are equal, so what's the opposite of that of this one? Here. So it's 7 times 2 equals, we'll do that in a minute. Then I know I have to find out this one, which I don't know what that is, and this one, or this one, it doesn't matter. So I do know this one because I just found the one right above it is 7. So if this is 7, this has to be 7. So what is this going to be? Well, what's the opposite side of this one? It's 50 over here. So it's 7 times 50. Now, this is my area model. What it basically has done, it has broken up my big multiplication problem, 52 times 37, into 4 smaller partial products. The area model is finding your partial products. So let's write down those partial products now. It's 30 times 2, which equals 60. It's 50 times 30, which equals 1,500. And it's 7 times 50, which equals 350. and it's 7 times 2, which equals 14. Now all I have to do is go and add all of these up to get the total area. So they're definitely not lined up, so I need to go ahead and redo that. I can add these two really quick in my head because it's 1,500 plus 60, so I know that's 1,560. 350 and 14 should be easy to add together. I know I said only two at once, but we have a lot of zeros here, so that should be okay. That'll be 4. This will be 6 and 6 is 12. This will be 9. So the answer is 1,924. Now, let's quickly look and see how that would look over here when we only have 2 parts. Okay, so to get the 2 parts ones, we're basically going to be doing the same thing over here, but we're not going to break apart 2 numbers to get 4 different parts of each rectangle. So we have 1 part, 2 part, 3 part, 4 parts. We're not going to do that. We're just going to break apart one of them. It doesn't matter which one you break apart. You can break apart either one you want. I'm going to break apart 37 into 30 and 7. So from here to here is 30, and then from here to here is 7. Then over here, I'm going to leave 52 alone. I'm going to leave that be 52 from here to here. Now, I have 2 different parts, right? So what is my area for this part? Well, it's 52 times 30. I can do that. I know how to do double digit when one of my digits are zeros. And this one right here is 52 times 7. And I also know how to do that because I know 2 digit by 1 digit. So if you know that, 2 parts probably might be a little bit easier for you than the 4. Not that it's easier, it's just less work. So now let's write down what our parts are. We have 52 times 30. So I can go ahead and write that up here and redo that up here. 52 times 30. This would be 6. All right, this would be 1,560. And this would be 52 times 7. And I'll rewrite that right here. 14, 35, 36, which will equals 364. Now what do? Instead of adding the 4 parts, I need to add the 2 parts, which I've already lined them up, so I can do that here. That'll be 4. This will be 12. Carry my 1. This will be 9, excuse me. And this will be 1. And again, I have the exact same answer, except for I have 2 parts here. 1, 2. And I have 4 parts here. The main thing is knowing how to find your lengths and your widths of each rectangle. Once you do that, the rest of it all kind of falls into place. Now, I want you to go and practice on your own.